Good morning. This is reading week 8 for Physics 2211. This week, the main physics idea was to expand our understanding of the energy principle to include other types of energy, namely potential energy. Potential energy is one of those staples taught in high school physics courses. We learned about kinetic and potential energy together, with the knowledge that kinetic energy is the energy of motion, and potential energy is the energy of location. However, after watching the videos, potential energy is a lot more than just how far an object is off the ground. The videos approach this topic in an interesting way, using a falling object, explaining that if we draw the system differently, we can include the Earth, where previously we had not. However, once you include the Earth, the work becomes zero, because no outside forces are having an impact on the system. It's the Earth, which is an object inside the system, that's making the object fall. However, we can't deny that kinetic energy was gained. So it must be that we lost potential energy. And potential energy's definition, as it is the negative of work. And it deals a lot with reciprocity, which is a topic we covered in an earlier lecture. The type of potential energy I have seen most often is gravitational potential energy. This actually does have to do with how far the object is off the ground. The explanation the videos gave used work, so it actually makes sense, rather than just being some formula we memorized and kept using, not really sure why. Gravitational potential energy values can also be set equal to Newton's law of universal gravitation, and that is what will allow us to use the values typically given in a problem. The next topic was energy graphs. This concept threw me for a loop the last time I learned it, and this time was no different. Potential energy is always negative. The reason being is that kinetic energy is always positive, because velocity squared and mass is always positive. However, the video did throw in that while the actual potential energy is always negative, the change can be either positive or negative, depending on what the energy principle equation basically needs. One important detail about this concept is that if an interaction depends on R and is attractive, its U decreases as the R decreases. And this is because R is in the denominator, and smaller numbers mean a bigger magnitude because it's negative, but it's a lesser value. One really cool concept was the bounded versus unbounded motion. If you think about it for a minute, it's just common sense. If you push a ball, not enough to get it to the edge of a table, it's going to stay on the table. However, they were talking about atoms and ions, which directly relates to my major of chemical engineering. The fact that giving the atoms just a little bit of energy can transform them from bounded to unbounded, which lets them become ions, is pretty interesting in my opinion. And the last big topic was electrical potential energy, and for that we just integrate Coulomb's law. We use reciprocity, as potential is equal to the negative of work, to get potential equals 1 over 4 pi epsilon naught times the product of the charges over R. Once again, we don't add a sign to this one because that's based entirely on the charges, whether they are like or different. The most difficult topic this week is one that was not actually covered in the videos. I understand the concepts, but I'm a little worried about my GlowScript coding abilities matching up. I'm going to continue to use the sites I found in the past to help me with the GlowScript and get a handle on how to do that, but it's probably a good thing I understand the concepts a little bit more this time before trying to code them. And one site that I did find furthers knowledge on the ionization topic is energyeducation.ca. It goes into detail about which types of elements ionize easier or harder and more. A second source I found was a chemistry textbook on LibreText. It actually explains the energy bound and that concept as the energy needed to break a bond. And this also relates to my MSE class, what we're doing right now. So that's pretty interesting on its own. But this has been Reading Week 8. Thank you for listening.